Linear word problems. I guess there's two things in math that I would say that kids tend to dislike the most. One of them is fractions, and the other one is word problems. And I tend to think that kids dislike them is because they're a little bit on the challenging side. But unfortunately, any type of real world math comes in the form of a word problem. Okay, um, so let's tackle it and let's see what we can do to sort of ease that stress around word problems. So your word problems are going to help you model a physical situation with your math tools, your equations, diagrams, and tables. And I've got um, some steps here, and I'm going to give you guys a mnemonic to remember these steps, so hopefully that you can be successful with your word problems. So the first one is make sure you have some let statements to define your variables. Use your let statements to write out expressions for quantities that we're interested in. We've got to translate and make a right and accurate equation. We've got to solve that equation, and then we've got to check the reasonableness of your answer. So, I don't know, some of you might know Miss McGee. She is a coach and she's an algebra teacher at Schrader. She gave me this idea a few years back, and it's called VWAC. Variables, equations, work, your answer, and check it. Variables, equations, work, your answer, and check it. So if you can remember VWAC when you come up to any type of word problem, I think that should be helpful. So it says, first one says, the sum of a number and 5 more than a number is 17. What is the number? It's its first experiment with some numbers, because I bet some of you could come up with this pretty easily just by playing around with it. So I don't know. I always start with, what if I started with 1? Okay, the sum of a number and 5 more than the number. So if my first number is 1, 5 more than that is 6, and it says the sum. And I know that that's 7. Well, they said the sum is 17. Okay, clearly that's not working. Whoops. So we would say, nope, that doesn't work. So then I might try 2. 5 more than 2 is 7. Does that equal 17? Nope. Okay. So you get the idea. Kind of play around with things, things that are familiar to you before you get into the abstract. So it says, let's come up with some let statements and an equation, and then we're going to solve that equation. So my let statement, so I'm going to say let x equal some number. Here's our variables. Our equation is going to be x plus 5 more than x. So that would be x plus 5. And we have to sum it, and that's equal to 17. Solving that, we end up with 2x plus 5 equals 17. We'd subtract 5 from both sides and get 12. We would divide by 2, and we end up with x is 6. Okay? So there's our answer. Now let's take our answer and let's check it. So if we said 6 plus 6 plus 5, does that equal 17? We've got 11. 6 plus 11, sure thing. That equals 17. Okay? Number 2, I'm not going to spend time on, but I'm going to give you the answer. Okay. Go ahead, flip the page. It says, the modeling process can become more complicated, obviously, when the information becomes more convoluted, so more sort of involved and wordy, and you've really got to be able to pick apart the English to get to the math. Okay, so let's talk about an age problem. So it says, Evie and her father are comparing ages. At the current time, Evie's father is 36 years older, okay, than her. 3 years from now, Evie's father will be 5 times her age at that point. How old is Evie now? And it says, before we start setting up the variables and equations and doing all that algebra, let's just try to do some guess and check. So it says, try a few ages for Evie now and see if any are correct. Think carefully about the information given in the equation. So if I say, I don't know, I'm going to try, what if Evie's 10? I don't know, I'm just picking an age. Okay. So if that's Evie, if I say she's 10, and her dad is 36 years older, so 10 plus 36, her dad would be 46. And now they talk about 3 years from now. So 3 years from now, Evie's going to be 13, and her dad is going to be 49. So now it says, go back, it says in 3 years, Evie's father will be 5 times her age. So if we took 5 times 13, does that equal 49? 5 times 13 is 65. So that's not her age. Okay? So obviously you could play around and kind of do some more guess and check. So let's take a look here. So if we say that Evie's age is X, we don't know it, and her dad is X plus 36. Now Evie in 3 years, right, is going to be X plus 3. And her father in 3 years is going to be that X plus 36 plus 3 years. Okay? So now let's take a look at what our equation would look like. So it says in 3 years, her dad's age is 5 times her age. So in 3 years, her dad's age, so that X plus 36 plus 3 is equal to 5 times Evie's age in 3 years. Okay? So now I would take, I don't even need these parentheses here. We just can combine like terms. So I'd get X plus 39. Distributive property, 5X plus 15. And now I've just got to solve for X. So if I subtract X and I'm going to subtract 15, 4X equals, that should be 24. X is 6. So how old is Evie? Evie is 6. Okay, and X plus 36. Sorry if you guys can hear Mr. Swenson. I don't know what Louie, our dog, is doing, but clearly Mr. Swenson is yelling at the dog. So I apologize. The Cowboys are playing right now, so who knows if we will hear him yelling at the TV any moment now. He's a big Cowboys fan. And then the Jets play at 8:30 tonight. Well, I'll be done taping by then because that really could get ugly. So, anywho, I digress. So, Evie is 6, and her dad, okay, is 42, okay, to start. And then in 3 years, she's 9, and in 3 years, she's 45. Holy cow, does it check? It says in 3 years, her dad is 5 times her age. So does 5 times her age equal her dad's age? It sure does. 45 equals 45. That could be your check. Okay? All right. Let's look at this next one. It's a money problem. It's another common type of word problem is money problems. So it says, Kirk has $12 less than Jim. If Jim spends half of his money and Kirk spends none, then Kirk will have $2 more than Jim. How much money did they both start with? All right, so let's talk. Jim has X dollars. Kirk has $12 less, so X minus 12. And then Jim after spending has half, okay? Or how did it say? If Jim spends half of his money, I'm sorry. So Jim, after spending, has 1/2 of his money. So 1/2 X, okay? So it says, and Kirk spends none, then Kirk will have $2 more than Jim, okay? So Kirk, okay, will have, remember, he spent none, okay, we'll have $2 more. So we're going to say, to make this equation equal, we're going to add 2 to that. Okay, add 2 to Jim's spending, okay, to make it equal. And now we've got our equation. So if I subtract 1/2 X, remember that's a 1X there, subtract 1/2 X, and we can add 12 at the same time, save us some space. So 1/2 X equals 14. So think to yourself here, 1/2 of what number gives you 14? Or we could multiply both sides by 2 or 2 over 1, and we end up with X is 28. So how much money? Jim's got $28 to start initially, and then Kirk has 28 minus 12, which is $16, okay? And then after he spent, he had half of that, so he had $14. So what does this all mean? So think about it. They said if he spent half of his money, he's got $2 less than Kirk. Is that true? Yeah. He's got 16. 14 is certainly 2 less than that. Okay? So I didn't talk too much about VWAC, but we've always come up with our variables. We come up with our equation. We show our work. We get our answer. We answer the question. And then this time we did kind of verbally check it. Okay? But you do know how to check. You can take your answer, okay, that 28, and put it back into your original equation, and you absolutely can go right to your calculator to check it. So let's go on to flip ahead a couple pages to consecutive integer games. I don't know why they call it games. I wouldn't say that it's games, but it's certainly so much fun. So here we go. Ready? Consecutive integers. So what are consecutive integers? They are, what does the word consecutive mean? All right, well, we know what integers are, okay, or real numbers. These integers are positives and negatives. Consecutive integers are any list of numbers, however long, that are separated by only one unit. So one right after the other. Okay, so here's a bunch of examples. And then we could take it a step further and talk about consecutive evens. So skip counting by 2s, only the evens. Or we could skip count by 2s, but only the odds. Okay? So it says, let's work with these a little bit. Okay? And it says it's important to kind of play around with these. I'm going to kind of bypass that for the sake of time, because that's just playing with some numbers. It's always good, though, to test things. Go to the concrete before you get to the abstract, okay? Because the abstract is the algebra stuff, the X's, all right? But we did that back in the last lesson, so I'm going to spend a little time in letter B here. It says, now carefully set up let statements that give expressions for our 2 consecutive integers. Using these expressions, set up an equation. Okay, so we do have to go back because I have to see what it talks about. So it says, consecutive for integers first. Okay, here's the equation. Sorry, I got a little too excited there. Here we go. 2 consecutive integers whose sum is 11 less than 3 times the smaller integer. So my first let statement, okay, if I don't know the integer, it's got to be x. Let x equal the first integer. Now, if consecutive integers are one right after the other, this next one would be x plus 1. That's going to be our second consecutive integer. And it's stated up here, it says two consecutive integers whose sum, okay, so we've got to add those, whose sum, so there's the first one, plus the second one is 11 less than 3 times the smaller integer. Okay, the smaller integer, 3 times the smaller integer, 11 less. Combining like terms. Now we've got a two-step equation. We just need to solve for x. So 1 equals x minus 11. We're going to add 11, and we end up with x equals 12. So if my first integer, my x, is 12, what's 12 plus 1? 13. Okay. Let's do a check on this one. Let's see, for lack of space, I'm going to put it right above our equation. So if I said 12 plus 12 plus 1, does it equal 3 times 12 minus 11? So I don't have my calculator up and running, so I'm going to do this in my head here. So we've got 12 plus 12 is 24, plus 1 is 25, and then 3 times 12 is 36, minus 11 is 25. If you typed that purple equation into your calculator, you absolutely would get a true answer. Okay? All right. So it says let's try some more problems. So talking about playing around with some numbers, so let's do that because I kind of blew it off on that first one. So it says I'm thinking of 3 consecutive odd integers. So 3 odd numbers right in a row. Okay, so I don't know. Let's start with 3, 5, 7. Those are odd numbers, one right in a row. It says when I add sorry, my phone's ringing. When I add the larger 2, so 5 plus 7, the result is, okay, that's your equals, 9 less than 3 times the smallest of them. 9 less, 3 times the smallest of them. 3 times 3. So let's say this is 12. 9 minus 9 is, 0. Okay, so 3, 5, 7 is certainly not my choice. Okay, I don't know. I might go to 7, 9, 11. So if we add our 2 larger numbers, because it says add the 2 larger numbers, 9 plus 11, the result is 3 times the smallest, so my smallest is 7, okay, 9 less than that. So this gives me 20. This is 21 minus 9, 21 minus 9. Okay, that's going to be 12. That doesn't equal 20. So you get the idea of kind of playing around with the familiar to now let's go to the abstract. Let's see. What are the consecutive integers? Okay, so our let statement. Let x equal the first one. Now, be careful. What's going to be the next odd integer? So odd integers are how far apart? This is 3. How far apart is 3 to 5? It's 2. So the next one's going to be x plus 2 is my second odd integer. And then x plus, what's the distance between these two here? It's 4. So x plus 4 is going to be your third odd integer. So I'm going to erase this so we've got some space here. And now let's do exactly what we did when we were playing around with the numbers. So it says the sum of the larger 2. X plus 2 is the middle number. Okay, plus x plus 4 is my largest one. The result is, I'll just shrink that down. The result is 3 times the smallest, so 3 times x, 9 less, minus 9. So now I put parentheses around it, but we don't need to. Be careful, it's just addition. 1x plus 1x is 2x plus 6 equals 3x minus 9. And solving minus 2x, we get 6 equals x minus 9, add 9, and we end up with 15. So what are my integers? 15. 15 plus 2 is 17, and 15 plus 4, 19. Okay? All right. So, okay, let's look at number 3, and then I'll give you the answer to 4, and we will be done. So now this one changes. It says 3 consecutive even integers. So I know my first one has to be x. So that's my first even integer. So now, how far apart are even integers? If your first integer was 2, the next one's going to be 4. So the distance between 2 and 4 is just we added 2. Does this look strange? Does it look like the last one we just did? And then the next one's going to be x plus 4 is my third even integer. Just always keep that in mind. Keep that basic, okay, example. If this is my first one, this is x plus 2. And then what's the distance between 2 and 6? It's 4. That's how we get these let statements. Now let's go to the equation. I have the property that when the difference, okay, difference means to subtract, between the first and twice the second is found. The difference between the first and twice the second, okay, is found. The result is 8 more than the third. 8 more, so 8 more means plus. The third, I'm going to put parentheses just to indicate that that's the third number, x plus 4. Now we take, and be careful, we've got to distribute a negative 2 there. Okay, make sure you're distributing a negative 2. So we get x minus 2x minus 4 equals, and now I said before, I don't need the parentheses there. There's no multiplication. Well, there's a multiplication of 1. That doesn't change anything. Just combine your like terms. X plus 12, clean it up, negative x minus 4 equals x plus 12. I probably would add x to both sides and then subtract 12. So I get 2x equals negative 16. Divide by 2. X is negative 8. So now let's go back up. So negative 8 is my first one because that's x. And then, whoops, what's negative 8 plus 2? It's going to be negative 6. And what's negative 8 plus 4? Negative 4. Okay, so we have consecutive, one right after the other, even integers. Okay, and they can be negative. It didn't say they had to be positive even integers. Okay, and the last one, they're just talking about 4 integers. I'm going to give you, that would be x plus 1, because they just said consecutive, one right after the other, not evens or odds. Those would be your 3 let statements. And then when you wrote your equation, you would get x equals, and solved it, negative 6. Nice job, guys.